I'm actually Granta, co-founder and material specialist at Natura Design, where we work with growing products and furniture out of mushrooms. So it's a little out of the normal relevance of going out and picking mushrooms to eat. But I'm here to kind of provide a bit more of a highlight onto what mycelium and mushrooms can be done more than just eating it for food and for medicine. So me and a friend from university, we co-founded Natura Design Studios, just really as a centralized hub to pool all the things that we're doing together. And personally, it was more of a direction that I didn't necessarily feel comfortable working as an employee for people. I have a very, let's say, spontaneous work ethic in terms of the direction I like to take. So being under my own steam was definitely the way to go. And sort of since starting Natura, things have just kept growing and growing in a fungal sense. And going back to your question of what I typically do on a day, it's split half and half between working in a lab. We've been lucky enough to set up a lab in the house with COVID rules going around. So we have a full lab, which if anybody is going to be in the meeting later today, we'll be presenting from there. But so half of my day is spent in the lab being really clean and really sterile. And then the other half of my day is the complete opposite, being in a workshop and carving wood, getting dusty, and making molds and forms to be able to grow new products and materials. That's what my day looks like.
Chris, I'm the community ranger for the RDP project in Caerphilly. I have quite a big area and a lot of different habitats around there. With this brings a lot of different fungi. Again, within fungi, within sort of Britain, we're talking 12,000 species. There's a massive amount. Ashley, you works with a few species.
Yep.
My expertise, I probably can name about 1,000 out of those 12,000. And that's, some of those you can only do with under the microscope because some of them are very, very hard to ID.
Yeah.
But I try my best.
I mean, and that's not even really the limit of the fungi that are out there. Like the predictions are to be 2 million different species worldwide, and we've only discovered about 15,000. So definitely in terms of learning, especially the Latin names of all those species, like that is a real commitment to go down.
Yes, it is. Definitely.
Yeah, I mean, in terms of materials as well, like you're quite right. I've only worked with a select few species, but if we think about the materials that we can make out of the small amount that we've already discovered, like tapping into the extra 2 million species, you could be creating fungi that are sentient completely and can recognize you and all these strange things.
Yes, there could be one day.
Take that one, Chris, if you want.
Go for it, Ashley.
Yeah. So mycelium itself is the actual filaments that make up a mushroom. So it's a network of cells, single cell organisms that spread out in search of nutrition to digest. And in doing so, once it is got to a point where it's ready to reproduce, the filaments actually knot together to create an actual structure, which then performs the function of reproduction. So producing spores, or if it's an asexual one, just emitting spores in its hyphal state. So that's at least my knowledge of what mycelium is. And definitely in terms of the species and the difference between the different types of mycelium, I'm not as familiar with, but it does vary a lot depending on you actually have types of mycelium and the characteristics, the way they grow, even the size and structure of them, which maybe Chris can highlight on a little bit more.
Yeah, well, within the fungal kingdom, you have the decomposers, you have the breakdown ones that break down, and then you have the ones that work with others. So they work with trees. They share nutrients. They take nutrients out of the ground, share it with the trees, and the trees give back. And then you get the other fungi which break down the wood, the lignin, everything in it to release all the nutrients back into the environment. So there's a lot there that they do, but again, we haven't got onto everything that they do. It's still an underappreciated species.
Yeah, I guess what their most obvious and primary thing is that they are decomposers. They are like nature's recyclers, is how it's typically termed. So it's breaking down all the woody mass to be able to release the carbon and nitrogen back into the soil for plants to reabsorb up and reuse. So at least in terms of its main function on Earth, it is our recycler. If we didn't have mushrooms, we wouldn't have soil, and if we didn't have soil, we wouldn't have trees, and then we would just be a barren landscape. So there's a lot to thank fungi for.
Yes, definitely. And again, fungi, when they are stressed or when they want something else, they can hunt as well. There are instances of the hyphae catching live insects to digest. So there is that as well. We can learn from that.
Carnivorous.
Yes.
Yeah, I mean, going on from that as well, if you look at things like slime mold, and also there's a lot of parasitic species of fungi that will actually hunt down and brainwash insects into changing its behavior. Like there's ones that will infect an insect and actually force it to go and drown itself, because the fungi actually requires water to germinate. So it's very much like the baseline, the inspiration of a lot of the movies for like World War Z and things like that. You can definitely see how it could be scary. I'm sure there's a country that is looking into biotechnologies in terms of warfare using species like that. But like Chris was saying, there's we've only really just scraped the surface of what it can do. Like it must only be really in the past 100 years that we start to reconnect back with fungi from such a basic form, especially given that like back thousands and thousands of years ago, it was clear that we had a more intimate knowledge of what fungi is and how it can be used. But unfortunately, over time, we have lost that information, and now we're trying to crawl it back and see what else we can do with it.
So how old is fungi, roughly?
Oh, God.
Do they have, is there some kind
Google.
of... Yeah.
Well, I mean, in terms of first early reports of humans using fungi, the Otzi the Iceman is the iconic one, where it was carrying Fomus fomentarius, horseshoe fungus, on his hip, because back then it was used as, you could use it to make an antibacterial tea, you could use it for a salve, you can also carry fire with it. So one of the nicknames of that species is called tinder conch, because you can actually split the conch down down in the middle, put a ember in it and close it up, and it will actually hold and carry fire really well, to a point where you can have it strapped to your waist and you're not going to be set on fire, and it keeps it really nice and dry. So that was like, they believe that was the first start where we actually transported fire, and therefore we could start going up to warmer climes, migrating from Africa to colder plains. So in terms of the first uses of mushrooms with humans, that was about 5,000 years ago. In terms of when mushrooms first appeared, I think it would be many, many millions of years ago.
They're a simple structure, but they've come on such wonders now.
Yeah, yes. I mean, there's some fossil remains and like dramatizations of what fungi used to be in like the prehistoric periods, and they imagined that they were as big as trees, these mushroom fungal structures. One of the reasons being because the atmosphere was a lot more dense, so therefore the metabolic rates of a lot of the species and animals as well could allow them to grow to be much larger. So imagine having like a mushroom tree in your backyard, this huge towering thing. Like, yeah. try climbing that. I wonder whether it would be spongy or not.
I've seen a couple of things by Paul Stamets and his take on the history of fungi, and there's various sites around the world really where they reckon, you know, fungi, as you said, Ashley, were as big as trees, and at different periods, especially after when they thought there was a meteorite strike on the planet, that fungi were one of the main living organisms that survived and colonized soon afterwards.
Yeah, well, I mean, even if you just think about the fact of what I was telling you about yesterday, Dylan, that the spores, the mushroom spores, can survive space. So it's not far-fetched to think that like that is always going to be the last thing to be living on the planet, or the thing that starts traveling over onto different planets. Like they have to actually scrub and make sure that when they're doing any trips into space, that it is as spore-free as possible. Because imagine you do a landing on the moon and instead you've brought lots of spores on the outer shell of your capsule. That environment, that ecosystem is now compromised. If you ever had, you know, the right conditions for mushrooms to start growing again, you're just going to get mushrooms from a different planet starting to pop up, and you've just changed the balance of it completely just because these spores are so resilient.
So it asks the question, what brought the spores to planet Earth?
I mean, it could have come alongside us, you know. It could have come on the asteroids, starting to become the single-celled organisms. It could have been something completely different back then in terms of its structure, but you know, with the evolution of everything, it started to become more fungal based than it did to plants and animals. But funnily enough, we're more related to fungi than we are related to plants. So in terms of our ancestry, we're a lot more linked to mushrooms than most people think. So yeah, you're all mushrooms.
My interest starts from when I was little, 8 years old, younger, just, you know, running around the woods, having a, you know, looking what's there and wanting to know exactly how, you know, what the names of these things are. That's what I've been since I was little. I wanted to know the name of everything out there. With regards to what I do every day, again, with the project, what I'm trying to do is get people out and about and get people to look at what's around, look at the nature, and just to be aware of their surroundings. Like within the area, they are such a short walk from the main town of Caerphilly, just to get out into somewhere that's quite wild and quite a few things growing. And if they just, you know, stopped and looked, it would be really good for them. Yeah.
You have a lot of engagement with the general public in your work?
Yeah, when I'm out and about, people always ask me, you know, why I'm squatting at the side of the road. You know, taking photos of these tiny little mushrooms, or asking me, "Oh, are you going to eat that?" And there's lots of different things that they ask, but everybody is interested in mushrooms and, you know, what they are outside.
Now, what is their advantage within the woodland setting?
Again, lots of different mushrooms. Some of them are, you know, tied in with different trees. Like you got silver birch, which has a host of different species that only grow around silver birch. Yeah. And again, this is what you're after. You need a diversity of trees within a woodland setting, so that you can have a lots of different mushrooms around, just to help, you know, with the health of the woodland. Yeah, and again, there's some recent research coming up about communication between all the tree species that is using the hyphae. So just using the links between all the trees to communicate with each other. Again, it's still early stages, but there may be something there.
Yeah, and also they do a lot of trading as well, just to add on to that. So the mycorrhizal network. So the mycorrhizal is when it's connected with a tree. And there's a lot of it's almost like a mushroom stock exchange. It's like, you know, I'll take these sugars from this tree because I can't produce my own sugars, and in exchange, I'll give you nitrogen, I'll give you carbon, and it's just like a constant trade. Which they were doing studies as well, and it never stays the same. Like it always fluctuates depending. And then as well from that, they actually have I guess a soup kitchen, I would call it as well, a soup kitchen function where if one tree is struggling, so say like you had a tree that had been chopped off or, you know, had been snapped in a storm, the trees and also the mycelium around it will actually start redirecting nutrients to that damaged tree in order to help it get back on its feet, because the mechanism is a forest is a lot stronger together than just a single tree. Like if you think about how many single trees you see out there with.
Oh,
You actually.
you just had a freeze there, Ashley. We'll carry on. Yeah. No, what's your take on that, Chris?
Yeah, if I go back to sort of a single plant species, say in the orchids are dependent on fungi. They need fungi. Then, you know, the seeds need to find a fungal host, and the orchid needs to take the nutrients from that fungi for at least 5 years. So there's a barter there to say, oh, well, if you give me some sugars and help me grow for the next 5 years, after that, when I produce leaves, I will give you sugars back.
Right.
And they can see in the roots of mature orchids, there are blooming colonies of fungi within them. So you can see that, you know, it's a good relationship, but sometimes it doesn't work out. If the orchid isn't producing enough sugars for the fungi will eat the orchid. So there is sometimes talks break down, and that happens.
It's very.
Again, you will see within the woods you have certain colonies, and some of them will not mix with others. Some of them will stay away. You get these lovely rings as the hyphae are working their way out, and you can see the fruiting bodies that are on the edge of the rings. So they're, you know, trying to spore a way to get further away from where they are. And again, it's just like colonizing the whole woodland. You know, there's a fungi that is in America that spans, I think it was either 3 or 5 states. The same fungi. It is a really, really big organism. Within the gill structure of the fruiting body, so around the woodland, you'll see these fruiting bodies. They're all shapes, all sizes. You have gills, you have pores, you have veins, surfaces. All will give off spores. Each one of them, thousands upon thousands of spores from each fruiting body. These will be released into the woodland and hopefully be carried on the wind. There are some of them which, and most fungi that will produce their own wind if there's no wind around. So they'll create a temperature variance below the cap, and that causes the spores to come out and rise above the cap. And if you look at, there are some lovely YouTube videos around of this happening by a light being shone behind it, and you can see the spores actually being released and going up and over the fungi because of this, their microclimate they're creating.
That's incredible.
It is when you watch it, and when when you see it for your own eyes, it's amazing. And the best experiment you can do, if you pick a fruiting body, bring it back to the house, and just do a spore print, but slightly raise it off, you'll see it moving in one direction. If try and do no draft around, and you can see that that's the microclimate it's creating.
Yep. So I am relatively new to the fungal world, let's say. I only started working with mushrooms about 3 years ago now. It was in my final year of university. I was exploring potential materials that didn't have to be made from like petrol or chemical-based plastics or glues or binders. And through doing a lot of the research in my final year, I stumbled across a furniture designer who was attempting to grow lights, mycelium lights. So these are structures grown with fungi as the binder, but using organic substrates such as wood shavings as the substrate that it sort of bonds together. So I started coming down to help out with what he was doing, and quickly fell in love / got hypnotized by mushrooms. And then kind of since that point, I have dedicated all of my time into sort of experimenting with it and seeing what materials can be formed using mushrooms. So that is kind of how I got into it. So at the moment, I do a lot of exploration in terms of my own design of furniture. I have a product here. So we do things like these bowls, which are made from spoon carving waste. So it's kind of meant to be a circularity of reusing, although it's not necessarily a damaging waste resource, but it's closing the loop on a waste process such as carving. And the material you can create is quite hard, quite durable. It's texture-wise, you can create a lot of different textures depending on the species you use. So I do a lot of playing around with that, basically. And other than that, I do a lot of education. I consult with a lot of companies to help them set up their own sort of production systems. And yeah, just kind of seeing what quirky and wacky things we can make with mushrooms. So I guess the primary kind of benefit to what fungal materials can do is the fact that it doesn't require any additives or chemicals, and the product itself, if it ever gets to the end of its life where it's not wanted or it gets broken or anything like that, you can break it down and mix it into your garden, mix it into the soil, compost, wherever you'd like, and within 6 months it's compost. So the actual disposal of the product improves soil condition rather than being negative, like you would think about, your phones and stuff like that, like the plastics and metals in there that last 500 years. So a lot of the products that we do are sort of aimed towards being as durable as the customer's interest is on that product. So, they can last up to 30 years if you look after them, but, we want something that is easily compostable, easily disposable, and not a cause of rising landfill or anything like that. In terms of application, it's similar to discovery of fungal species. It's very early days in terms of what has already been explored. So far, there are people doing textiles, solid materials, insulation, packaging, even doing like a living filtration system. Where you can pass through water and the living mycelium will actually pick out and grab things like nematodes and other chemicals and stuff from the water system. So there's a lot of sort of applications that are being explored currently, and in terms of future applications, it can be nuts. Basically, like you can teach fungi to digest certain things, and this ranges all the way up to petrochemicals. So people have taught it to digest cigarette butts and actual oil and things like that. And the previous contract that I was working on, we were actually developing a species to digest plastics. So in terms of application in the future, it just takes a little bit of time, a little bit of expertise. And, in the future, we could have a compost bin that's for plastics as well as for green waste. So the day we reach that, the day I'm like, I'm happy, I'll retire now. The applications are massive. Sorry, Chris?
In Chernobyl now, they've discovered the fungi is actually, using the radiation and breaking that down. So it's
Chris, could you just pull your mic up a little bit so we can hear you a bit better?
Sorry, can you hear me? Yeah. So the fungi itself has looked at the available energy around and thought, actually, I can use this radiation here to create something. So another application for the future to clean up radiation.
Yeah. So those species are classified as radiotropic. And, you know, even just in terms of that application, imagine having spacesuits, living mushroom spacesuits that are actually able to digest the radiation that is you're being blasted with. Like it's like sci-fi level, but it's not even like that far of a jump ahead. You know, like the core building blocks are there. It just takes, you know, someone to put a little bit of time and effort into perfecting that. So, I mean, I like I was saying before, Dylan, I held up many a pub discussions with mushrooms and potential uses of it, just because it's like there isn't really a limit to it at the moment.
Yeah.
Like the only negative, or not negative side, but weak point of mycelium and mycelium products is they're not really designed for use with water or like long-term moisture exposure, just because it's like it's the coin side of its best side and its bad side is with water you get bacteria and then you get decomposition. So it's like, you know, you wouldn't have products in the kitchen, not in the kitchen, in the bathroom, because they would start decomposing down, which, you know, it's good when you want it out in the garden and you want it to start decomposing, but when it's, you know, you're wanting it to be functional, it's not its best feature. But that's really its only weak point at the moment that people have been able to find. So yeah.
What's interesting is that there's, and listening to some speakers on the internet, is that people are starting to adapt fungi and play around with how it pollinates, and how you, if you've got a functionality you want the fungi to perform towards, you can play around
Train
with it.
Yes, yeah. So mycelium and fungi, similar to bacteria, can go through what's known as directed evolution. So it's really a fast-paced evolution that we wouldn't necessarily see in ourselves, but because the organisms are so simple in terms of the chemicals they're producing, you can really change the instruction book that they're working with. So in terms of what I was saying before about digesting plastics, it's really just a case of exposing the fungi in a stressed environment to a single food source, and to a point it's, you know, swapping out chemicals. It's trying to see, how do I break these bonds? And then as soon as it figures it out, it's like, boom, right, I'll remember that one. And in terms of plastics, like it's kind of strange to think, but it's so calorific. Like if you try burning plastic and you think about how much flame and smoke comes out, that's how much energy is locked up in that plastic. So as soon as fungi learn how to digest plastics, they're going to be like, yeah, we'll stick to the plastic diet. Like it's much more nutritious than this crap wood that has nothing in it. And at that point, we'll have plastic eating mushrooms everywhere, digesting everything. And, you know.
So it's the calorific value which is the important thing for a mushroom to expand its colony, I presume.
Yeah. I mean, its sole purpose in life is to digest. So if it's able to get itself, get its hands on a better food source, a more nutritional food source, then it has to work less. And just like us humans, we'll just settle into a nice, comfortable lifestyle and not really move off our chair and just have takeaway food all the time. So fungi are very similar in terms of that. So if you show them the carrot on the stick, they will quickly run for it.
Well, a couple of other applications which I thought were, you know, they're staggering really and very poignant for our time now, is some research done on antidepressant, and the results coming back from that are absolutely staggering. Turkey tail for cancer, and they've had some incredible results coming back on that. And soil improvement, which you've mentioned as well, especially when there's been contaminants in the soil, such as an oil spill or something like that. So I don't know, Chris, could you tell us anything more on that? And have you come across any work in this area?
I think it's froze.
Sorry,
I lost everything for like a minute.
That's all right. I was just mentioning some of the benefits, the other benefits I've come across with fungi on antidepressant, cancer treatment, and soil soil improvement, and have you sort of come across any work in this area?
Again, working with some of the, having a look at the fungi around, and if you look back into the history of fungi, you'll see that, the main one is the fly agaric. And the fly agaric was used a lot by a lot of people, going back. This is where we get our fairy tales.
Not just people though, either.
Not just people. Again, animals use fly agaric, they eat it, they love it. There are some reindeer around, we've seen that absolutely, they if they smell something going, they will flock for it, really. They love it, and they know the benefits from it. So, they've got the benefits from it. It's just we haven't quite got,
that knowledge
yet.
Yeah,
that knowledge of what happens to us. Yes, if you eat fly agaric, you do get a massive trip off it. But again,
that's what the reindeers are looking for, let's be honest.
they are, and again, it's something to get away from, the bitter coal. There's something, that's what they want. And they know that this is beneficial for them and not something that's going to kill them. Yeah, there are a lot of fungi out there that will kill you, and some of them in brutal ways. So, it's, bear in mind, research, we need a lot more research into fungi effects.
Yeah, and if you are going around in the wild and picking mushrooms, make sure you're 100% sure on the idea of it, just so you don't either trip or die in general. But it's very interesting that you mentioned the reindeers with the fly agaric as well, because there's a lot of folklore around the fact of the Inuits and people like that used to feed the reindeers, specifically the fly agarics, to actually take their urine, because the fly agaric, although it's hallucinogenic, it has a lot of compounds in it which our body rejects, and it makes us feel quite sick and ill. So they actually discovered that if you process it through a living being and collect their urine, then you don't have any of the side effects, but you have the hallucinogenic compounds in it. So there's been talks about the stories of Rudolph the Red-Nosed Reindeer and flying and stuff like that, that it's actually down to the fact of feeding it the fly agaric and having these reindeers tripping, basically.
That's got a completely different spin on Christmas and Father Christmas.
Well, exactly. Well, they think the colors and things like that, like, I know it's all kind of hearsay at this point, but the reds and the whites of the fly agaric, they think that's what kind of inspired the color palette of Santa Claus and Christmas. And going further on from the reindeer story, the Victorians realized that this system works with not just reindeers but with people. So they used to actually feed it to lower class people, collect their urine, and then they'd have a tripping party, let's say, in the Victorian ages, and everyone would come together and have a drink, and they would all have hallucinogenic visions after drinking this other person's urine. I mean, upper class living. It's a fine vintage. But in terms of actual positive medicinal benefits, you're quite right. Turkey tail has a lot of anti-tumorous properties, and as well reishi, so Ganoderma lucidium, which you might have your fruiting block still nearby. That's probably the primary one that they're focusing a lot of their medical research on in terms of anti-tumorous. Is really it boosts your own immune system. That's its actual kind of mechanism. So it really pumps up your immune system to be able to fight and defend off things, specifically like tumors and cancers. So there definitely is a lot of potential in terms of medical benefits from that. And then soil remediation as well. So a lot of mycelium will actually hyperaccumulate heavy metals and toxins. So in terms of being able to clean up, say, like an old demolished working site, like they're able to actually extract those compounds out of the soil, to which you can, take those mushrooms and actually dispose of them properly, or you just let nature keep doing its course, and eventually the chemicals will kind of leach out of the system. But it really helps with, turning a brown site back into a green site. It does take quite a few years, but it's really has a good potential in terms of being able to replace what damage we've already done. Because before then, it was known that once you've built on some land, that soil condition is ruined for a long time. But now might actually be a possibility of being able to kickstart it back into giving it back to nature. So the species right here, so this is Faunus fomentarius, growing on the silver birch. So they found out recently, and I believe it was Paul Stamets that began the core of the research, but they discovered that honeybees would come up to these species, and depending on the conditions they're in, they sometimes secrete a metabolite. So a metabolite is basically a liquid chemical they produce, and that chemical is known to be antiviral, to be antibacterial. And they found that the bees would actually come and rub themselves on it and then go back to the colony. And this was, taken advantage of in terms of one of the biggest threats we're facing in terms of our pollinators is colony collapse disorder with bees. So this is a viral disease which weakens immune systems, their wings don't properly develop, and the colony just collapses really quickly. But they actually found that they were trying to medicate themselves by rubbing themselves on these conchs and coming back and spreading it further. So now they're actually doing quite a lot of research into being able to produce that chemical and actually have almost bead feeding stations which have this supplementation included in it to help kind of boost the numbers back up to what they once were. Because it is really true, like we lose bees, and especially as well if we lose flies, we lose all our pollinators and our crops. Well, I mean, worst case scenario, we lose them all, but financially and economically, it takes so much more money to produce food. Like there is farms in China where it's hand pollinated, and you think about one person with a little cotton bud just tickling flowers, going from one bud to the next. Like the amount of time and money it costs to actually produce food, like it will start becoming a point where we can't actually afford the luxury items like fruit and vegetables because we don't have enough pollinators. And then we all have to swap to a McDonald's diet because, we all know that's made out of just waste resources. If you think about cultures and tribes in the Amazon and their knowledge of, combining certain plants together and cooking it at a certain temperature to create an anti-venom for only one type of snake, you think about how long, and I'm not sure whether it's trial and error in terms of, did we get it right or not, over thousands and thousands of years, or if it was something more than that. But, you think about all that information that can be lost just, simply overnight. We are carriers and vessels of that information. But at least now we have the internet, and hopefully, we're going to start this recollection, this rejoining of all that information together in one forum that won't ever disappear. And from that, we're going to see quite huge expanses, both in, medically and materials and just in general, like being able to overcome a lot of the problems that we as people are starting to face. Like we're definitely way outnumbered in terms of how much population we have. Like we're way too big. The only way we can overcome that is to actually learn how to live comfortably in the environment that we're in, and to a point where we're not actually doing damage to anything, but we're actually living symbiotically. I'm
going to thank Ashley and Chris for your time this morning. Absolutely brilliant discussion. Like you say, it can go off in many different directions, as it has done already, and probably worth maybe another webinar at some point, I would say, to pick up on some of these topics and maybe delve a bit deeper in them. And I'm particularly interested in how that relationship within the woodland setting and the benefits that brings to us.
Yeah, well, hopefully next time we can be in person and maybe even set up in a forest.
There we are. That's the next. That's the next webinar to happen. Yeah, fantastic. Well, thank you everybody. Diolch yn fawr.